Welcome everyone. So we made it to day 12 of Just Start Programming, the Rust programming language. First of all, I would like to thank those who subscribed, who supported me. It's really great to know that there are a few people who supported this kind of content. I know it's not something you can uh, easily view and pick up the knowledge, because for me this is I would say this is a journey, a learning journey. So if you are with me viewing this content, all the best to all of us. And let's start. Yeah, so for today, I would like to take some time to review uh, what we have covered the other days. I think we stopped somewhere under traits. So let me just glance through just to refresh our memory. So from what I can remember, traits are like interfaces, yes, here. Often called interfaces in other language. And how we can do that, we do something like this. So this is a publicly accessible trait for summary. So summary could be an enum or a struct. Is it possible to be an enum? Oh, I might have forgotten. Yeah, but for the time being, let's just go through summary, where you define a function called summarize, and this is the first parameter, self. It returns string, and I think the important part is it ends in a semicolon. So as you notice, there's no implementation here. Yeah. And then how do we implement the trait on a type? So here, news article is a struct. If we wanted to use summary as the interface or the trait, yeah, so we'll replace interface with trait. So you're implementing impl summary for our news article. So you use the same function signature for summarize as what you have here at the top, summarize. And then you bring in the implementation like this. So this one is quite simple, so it's mainly formatting the string. At this point, it's not displaying the string, it's just formatting it. So self headline, self author, self location. So those are the values here that is being shown. And then you can do the same thing for social post, where it's a struct, and then you implement summary and then summarize. Yeah, so as simple as that. So here, aggregator, why do we have aggregator? Uses, so this is how we do modules, and there's a way to shorten. Instead of having use aggregator social post and use aggregator summary as another line here, you can do something like this, separated by a comma. Social post. Okay, so you're assigning the value string horse books to username and content, reply false, post. And then when you call summarize, it will show username content because it's social post implementing summarize. Okay, default implementation. So a trait can have a default implementation. So here, summarize string. If the one who implements the trait doesn't implement anything, then it will make use of this implementation. Yeah. So here, summarize, news article. So this one will be printed, news article available, read more, because that news article was previously implemented. Yeah. So it's only when you did not implement, then the default implementation will be called from the trait itself. Creating a default implementation doesn't require us to change anything. Okay, so here it's also possible that you have, okay, now you have two functions, summarize author and summarize. Okay, so this one will illustrate that since summarize has an implementation here, so you are not obligated to implement it here. But for summarize author, you have to implement it under social post. What else do we have here? Traits as parameters. So this is one, I would say, one of the features and possibility that you can do with trait, meaning in another function, in this case it's notify, you can pass in a reference to an implementation of summary. So summary is the trait, and that would be binded to this item variable, so that within your function it's easy to call summarize from here. Okay, instead of concrete type of item parameter, we specify impl keyword and the trait name. Okay, trait bound syntax. This one is difficult to remember, yeah, because after a few days I've already forgotten about this. So I know it's not easy, but let's take some time to review what this syntax is all about. So it says here the impl trait syntax works for straightforward cases, but actually syntax sugar for a longer form known as a trait bound. So it's a syntax sugar. What does it mean? So the same function notify, you have an item, but you have the flexibility of a type here. Reference to a type. But in this case, you explicitly put in, okay, type T is summary. Trait summary. Yeah. So a type could be a trait. That's how I see it. Yeah, so here, of course, summary is a trait. I think later on, once we gain the experience in programming in Rust, maybe at some point in the future, I'll come up with a more concise, summarized form of Rust tutorial. Yeah, but as of now, I have to admit I don't have the skills yet. I can only read through the documentation, so it's like when you view this stream, you're going through the documentation together with me. And if I have some insights here, of course, I'll mention it. Or if we do experimentation here, I'll show it to you guys. So that aside from the document itself or from the book itself, maybe we'll open up another view or another perspective into this programming language. Okay, let's move on. This longer form, okay, so it's just the equivalent of the previous one. You can do it two ways. And then you have impl trait syntax is convenient and makes more concise code in simple cases. While the fuller trait bound syntax can express more complexity in other cases. So here it looks convenient, but the fuller trait bound syntax can express more complexity. Oh, while the fuller trait bound syntax can express more complexity. In other cases, for example, we can have two parameters summary doing the impl trait syntax looks like this. Yeah, so it shows complexity. But if we do it this way, that means, yeah, it's here. It's illustrated here. This one becomes T. They're referring to exactly the same type, which is summary trait or trait summary. Well, it's good to know that we have that option. Either way, by knowing this, we would be able to understand what it means in code. All right. So here you can specify multiple trait bounds with a plus syntax. This means that item can be both a summary and display. Not sure if I had that here in the code previously. Okay, so we don't have it. What's display? Display implementation. We don't have. Okay. Clone, you can have clone as well. Why not we try this one out just to refresh our memory? So we have summary here at the top. Maybe I'll add in another one called pub trait display. And let's create a function. Show, maybe show. It's not in the document. We're just making this up just to test. What was that? Multiple trait bounds with the plus syntax. Let it return string as well. Okay. And then I will implement it here also, default implementation. This is trait display. Okay, something like that. Okay, so what is it that we wanted to do? We'll create a function over here. Function. Notify. So it says you can use plus. We create the bounds first. here. Item colon. So we have an ampersand to summary plus ampersand to display. See, like this. Return string. Can we do something like this? Will it return string? No. So string. No. Oh, we don't need to return anything. But what is wrong here? Summary plus display. Oh, impl. So can I do something like summary and then here pl display? Is there an error? Snake, case snake. Missing type for function parameter. Where did I put display? Oh. Okay, so here, because it returns string, you don't need to put the semicolon at the end. impl display. So does it complain? So we cannot write it like this according to the document. Need to have summary plus oops. Display. Still doesn't work. Ampersand impl should be inside. Impl. Okay. Then here I don't need to do anything. I think by default I should call the default implementation in both summary and display. Debug, we can just call notify item social post percent social post. We're borrowing social post. Display trait bound display is not satisfied. Oh, social post is not. Then how do we call trait? Item let summary display. Let's do no, cannot do it like this. So how do we call notify? I think here if we delete this, then put item format. Item notify. No, item summarize. Because we have summarize in item and then item is notify. Is it notify? Show. Show as display. We can return this as string. And here how do we use it? We can have debug. Social post. And we call doesn't show actually. Notify. Okay, so let's think. impl summary, impl display. Okay, so does it mean that a type that implements summary and display? Social post implements summary, but it doesn't implement display. Or can we remove this one? Is it possible to remove this one? No. No, so but can we use social what's the error here? Social post display is not satisfied. So if we go back to social post, then it means this was my question last time. How can we implement both for social post? Does it mean that we need to by both I mean display and summary? So does it mean I need to put it here? Or social post. Then I leave it blank. Summarize. So summarize will be yeah, okay. So summarize will be used by social post here. Headline, author, location. Then display would be just what? This is straight display, which is the default. Okay, so maybe I'll comment okay, no need to comment it out. And then let's run this. Okay, social post summarize. This is this line. News article summarize it's this line. Then notify social post. Bob content ABC, so that is from this one. This is trait display, so which is the default. Okay, but the question remains, how can we combine this in social posts? Do we always have to do it like this? I think so. It has to be separate. Otherwise, if we put for display, let us display show. If we implement function show here, percent self, also string, nothing. Oh, now it complains. Method show is not a member of trait summary. Yeah, so it's not a member. Associate item definition into trait definition. Now show is added here, which we don't want to do. Okay, so we cannot do this. This one we have checked. Otherwise, it will be ambiguous. So in this case, it's clear. Okay, I hope you got that. So it can be done like this as well. Which one is simpler? I think this one is not that easy to read. In this case, it's easier. Okay, let's see. Notify. So copy this. Oops. What I will do is comment this out. So instead of doing like this, let me try to recall. Notify %t colon. So you have summary plus display. And here can remove it. Oops. Can remove this. And %impl t. Is it like this? No, no ampersand here. No, just t. Yeah. Why do we have t here? Should be like this. ampersand T. Okay. Ampersand T. Reference to type T, while the type is defined like this here. Here, reference to the implementation of summary and display. Which one is easier to read? I think here, display, we don't know if it's referring to the implementation. So it would be nice if you have impl here, but I don't know in the syntax why. And yeah, ampersand. So this one will like just enclosed everything. So which do you prefer? Do you prefer this or this one? Okay, let me come up with something else. Let's build some muscle memory. So here you have type, okay, I don't want T, but I will use U. No, maybe put notify again. Or maybe I'll put display summary. So close in angle brackets. And here, this is where we put the variable. We're borrowing it. Oh, this type, no, not T, but now U. And string. Okay, so it doesn't return anything. So let's make it return string colon from notify again. Okay. So we did not use notify again, so let's copy this. Put again. So we shall let's see. Notify again, social post, notify again. Yeah, because we are just returning notify again here. Item or item is not even used. Okay, so let's use item. Maybe what from item? Bob. Okay, let's use it. So instead of this, I'm going to do format, put something here, and then item that summarize. So we'll use summarize. So Bob content ABC, notify again. That should be the output. Item is already used. Turn string. Okay, to remove that. So the can return string, debug will show it. Yeah, so here Bob content ABC, notify again. Okay. So we've covered that. And here, clearer trait bounds with where clauses. Using too many trait bounds has its downsides. Yeah, so you have display plus clone and U clone plus debug. Here you have a reference to type T, reference to type Q, I32. Okay, it makes function signature hard to read. For this reason, Rust has alternate syntax for specifying trait bounds inside the where clause after the function signature. Trait bounds after the where clause. We can use where clause like this. Some function t and u, type t, type u, where. Oh, so you can do it here. Type t, display plus clone, u, clone plus debug. Okay, let's copy this. So you can do something like this. Then you can also do something like this. Okay, so it's complaining where can we name it into some function 2. Let's say issue I32 where there should be a why does it complain? Where doesn't have this? Okay, this one looks a bit weird. Yeah. What does it mean? Okay, debug. Consider importing this trait instead. Because it was using debug. So if we import, we need to do something like use. Oops, what am I typing? Use. Maybe it's in std debug dbg debug. So okay, so what's wrong now? Drive macro debug. Okay. So it should be this one. std format debug. std t debug. Okay. Now it's I32 since it is returning I32. Found something empty here. So can we do like this? Okay, of course it's not allowed. It's 0. Yeah, 0 is totally fine because 0 is I32. Display clone t and u. So t and u, t u. Okay, t u t t U, then you have T and U here again. What will happen if you change this into small t? Well, what does it mean? T, U. Yeah, to complain. It will complain. So we'll change this to capital T, where we are referring to the type, and this one capital U, type. Okay, so that is clear. Returning types that implement traits. Returning types. Oh, here, summary. Oh, that's possible. I don't know if you guys remember this or if we have covered this. It's also possible to return traits. Types that implement traits. Okay, return summarizable. Return summarizable. Yeah, social post is a struct and it implements summary. So what will it do? At this point, it does nothing. So it's like you're creating a structure where it will return these values. How should we interpret this? Social post will have the summary traits. No, because it's a summary trait and social post implements it. It means that, yeah, okay, by the name of the function itself, it returns summarizable. Summarizable. I think that would be nice if you have summary. So articles is also implementing summary. A news article, yeah. So it can be either social post or news article. Yeah, because it's a summary. Maybe we're interested in returning a structure, and then from return summarizable we can just execute the functions of summary. Okay, let's try that one. So here return summarizable, and then I can do dot summarize. Look at that. And then I think this one, if we put debug, what will it show? So social post way of displaying summarize. So summarize is read more if it's not implemented, but summary is implemented for social post, which is username content. So that will be username horse books. Of course, you're probably as you probably know, people. Okay, that would be the output. Yeah, horse books, of course, as you probably already know. Okay. Next, summary trait without naming the concrete type. Okay, but the code calling this function doesn't need to know that, as long as summarize is implemented. Ability to specify a return type only by the trait it implements is especially useful in context of closures and iterators. Okay, which we will cover in chapter 13. Closures and iterators create types that only the compiler knows, or types that are very long to specify. The impl trait syntax lets you concisely specify that the function returns some type that implements the iterator trait without needing to write a very long type. However, you can only use impl trait if you're returning a single type. For example, this code returns a news article or a social post with the return type specified as impl summary. Okay. This was the idea where we can switch, and then since they both implement summary, so either way you can return news article or social post by the switch. But why is there an error? Okay, returning either a news article or a social post isn't allowed due to restrictions around how impl trait syntax is implemented in the compiler. We'll cover how to write a function with this behavior in using trait objects that allow for values of different types. Okay, so this is not allowed, and it will be covered here. Okay, using trait bounds to conditionally implement methods. By using trait bound with impl block that use generic type parameters, we can implement methods conditionally for types that implement the specified traits. For example, the type pair listing 10-15, so this is 10-15, always implements the new function to return new instance of pair t. Call from the defining methods section of chapter 5 that self is a type alias for the type of the impl block, which in this case is pair t. But in the next impl block, pair t only implements the cmp display method of its inner type t. Okay, I think this is quite long. Let's see what we can read from here. Pair is a struct of type t. X is of type t. Okay, so pair can only take t. Okay, then implement. What is this? Implement. Okay, we're implementing pair t of type t. What does it mean? So if you have a function new, x is type t, y is type t. Oh, it returns self xy. So this one is self. Implement t display plus partial lord type pair. This one is not a trait. Using trait bounds to conditionally implement methods. Okay, impl block, we can implement methods conditionally for types that implement specified traits. Okay. Self is a type. Okay, self is a type alias for the type of impl block, which in this case is pair T. I think this is difficult to digest. Pair T, CMP display at self, self X, self Y, print line, self X. Okay. What does it mean? Pair T. This is pair, this is pair. What's the difference between this and this? So in this case, pair T, okay. It implements a trait. Implements a trait. Let's see how the trait was implemented. Oh, it's not here. But it implements a trait display and partial load. This is difficult to memorize. I think this part here is something we need to understand. That self is a type alias for the type in the impl block, which in this case is pair T. Pair T. But in the next impl block, pair T only implements the CMP display method if its inner type T implements partial ORD. Trait that enables comparison and display trait that enables printing. Comparison, printing. So it has both. By printing, is it this? Maybe. Okay, so I think it would be interesting is if we copy this and put it here. Okay, format display. Okay, can comment this out. Stuff. Doesn't implement format display. Okay. Format display. Oh, because of this. T doesn't implement. In formal strings, you may be able to use this for pretty print. Consider further restricting the type T with trait display. Trait display. Standard format display. How should we fix this? Didn't say how to fix. Okay, so I think because we had something like this display. So where is display? Show. I think because I did something like this. Okay. And anything that does this to comment out. But who is this display now? Should be this. There. Okay, so we can comment this out. Using it anymore. So pair is never constructed. New is never used. CMP display is never used. How can we use this one? Pair T. Mm. Compare display. Display is never used. Method in this implementation. Okay, so let's try pair new. Let's put pair new here. Pair test. Pair 1 plus pair new x is 10, y is 20, then pair 1 dot compare display. Okay. Our just number is y equals to 20. Why did it show that one? Because compare display self x. So actually this is still pair. Partial, or what does it mean? Less than, greater than. Okay, so is it this one? But this is just conditional with this is expression. How is it using partial word? Partial ord. Partial ord. Some self CMP other. Self CMP other. Can we modify this line? Is that legal? Self dot y dot CMP. I don't know why CMP is not showing. Oh, now it complains. Snap. Partial CMP. Hmm? Partial CMP. Okay, because the return is this one, option. You have to do something like this. What's that I was looking for earlier? Partial or here less than sum equal partial CMP. If and only if partial CMP AB. Okay, pair X. Yeah, this is okay. But you need to do a match. Okay. So what I will do what do I want to what is it I wanted to do here? Okay, I'll copy this block, put it here, and comment this out. And here, where some value num. Okay. What shall we put here? 0. No? And none. -1. There. No, not where, but match. Sorry. Match. We wanted to match. Consider semicolon where? 510. And this one, partial compare others. Borrowing. Self y. We just need to borrow. Okay. Maybe we display what is num. Num. Or return what is num. And none is -1. Why is it -1? Compatible types. Match arms have incompatible types. This is found to be of type ordering. So it's more appropriate if it's ord. Like this. Ord. And here, what shall we return? Maybe ordering. Colon. Do we have? No. Colon. And what do we have for ordering? Can either be less, equal, greater. Less, equal, greater. Less. Oh. Ordering. What? Arms have incompatible types. Why it is incompatible? Oh, okay. No, it's okay. Okay, so that was long. It took us some time to understand. Okay, so here I wanted to call something from partial ord trait, and that is the partial CMP. So we managed to do that here, where we use the value of self. So self is here. So that's x and y. So I'm comparing x and y here. Some will return ordering, so it could be less, equal, greater, but for none, since we need to return something, yeah, of course, equal may not be appropriate. But just for demonstration purposes, we can call partial load here. Okay. Display. Oh, no, that's already the end. What is here? 3. Trait, for example, we can turn integers into their corresponding string values like this because integers implement display. Okay. Integers can be converted into string because of display. So we just need to take note. An integer will have 2 strings. Blanket implementations appear in the documentation for the trait in the implementer section. Okay, then this is another concept. Traits and trait bounds let us write code that uses generic type parameters to reduce duplication, but also specify to the compiler that we want the generic type to have particular behavior. The compiler can then use the trait bound information to check that all the concrete types used with our code provide the correct behavior. In dynamically typed languages, we would get an error at runtime if we called a method on a type which didn't define the method. But Rust moves these errors to compile time. Okay, so compile time checking. We're forced to fix the problems before our code is even able to run. Additionally, we don't have to write code that checks for behavior at runtime because we've already checked at compile time. Doing so improves performance without having to give up the flexibility of generics. Nice. So generics and type. This is where we can play around how we can make our code more dynamic. No, make our code more to have flexibility, and we can reuse code as well. Yeah, but this part here is quite complex to understand. Implements T, so everything is T. Then here implements. Yeah, okay, this is for the new trait. Implement can have a trait. I think that's the trait bounds to conditionally implement methods. Trait bounds in implementing methods. I think we need to revisit this again and again to really absorb this one here. Maybe we can see it in some of the modules. Okay, but for today, let's move on to validating references. Okay, validating references with lifetimes. Oh, I hope I've mentioned that properly in my... Yeah, okay. In the description of the stream. Lifetimes, yes. Okay, it's correct. Let's continue. Lifetimes are another kind of generic that we've already been using. Rather than ensuring that a type has the behavior we want, lifetimes ensure that references are valid as long as we need them to be lifetimes. One detail we didn't discuss in the references and borrowing section in chapter 4 is that every reference in Rust has a lifetime, which the scope for which that reference is valid. Most of the time, Lifetimes are implicit and inferred, just like most of the time types are inferred. We only have to annotate times when multiple types are possible. In similar way, we have to annotate lifetimes when lifetimes of references could be related in few different ways. Rust requires us to annotate the relationships using generic lifetime parameters to ensure the actual reference used at runtime will definitely be valid. Annotating lifetime is not even a concept most other programming languages have. So this is going to feel unfamiliar. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime syntax so you can get comfortable with the concept. Okay, so it's a new concept. Preventing dangling references with lifetimes. The main aim of lifetime is to prevent dangling references, which cause a program to reference data other than the data it's intended to reference. Consider the program listing 10-16, which has an outer scope and an inner scope. Okay. What is wrong here? Let's try to check. Let R. Okay, R. Nothing was binded to R, so now this is another scope. We have x equals to 5. R will have, okay, R is here actually. R, wait. At this point, R is out of scope, it seems. Reference to X. Yeah, so R, there will be an error. Okay, so maybe let's create a new project for lifetime. Creates cargo new lifetime. Lifetimes. Okay, lifetimes. Then let me close the code. Open up a new Visual Studio Code here. Yeah, we're closing Copilot. If we use Copilot and I don't know, maybe we'll learn something, but I would like to learn the hard way. Okay, so copy. Yep, let's see, X. Oh, it did not complain about R. Ah, so these are the things that you won't see from here. Oh, yeah, of course, it will be here. It will be here. But from here, I think you'll get the insights more real time. Yeah. X does not live long enough. Borrowed values that does not live long enough. Yeah, I mean, R is the one borrowing X actually. X is dropped here while still borrowed. Does it mean that R is in scope even inside this one? But because R is referencing this, R when it comes out, this scope, then R, okay, borrow later used here. Borrow later used here, drop. Yeah, okay. X will be out of scope here, but R is still referencing X. So you end up having a dangling pointer. Yeah, okay, let's do that again. X, the scope of X is here. So you have 5 binded to X, and then R referencing the location of X. Then at this point, X is already out of scope. So you'll end up R referencing a dangling pointer. Yeah, so then it complains. Okay, so let's read through. Yeah, 10:16, 10:17, and 10:23 declare variables without giving them an initial value. I think it's this one. Declaring variables without having initial value. So the variable name exists in the outer scope. So it's, yeah, outer scope, meaning this scope. At first glance, this might appear to be in conflict with Rust having no null values. However, if we try to use a variable before giving it a value, we get a compile time error. Yeah, using a variable before giving it a value. So it means R something here. I think that one will have an error. So if I put in debug, easiest way is instead of printing, you use debug. Yeah, so uninitialized. Yeah. Okay. The outer scope declares a variable name R with no initial value. Inner scope declares a variable name X. Initial value of 5. Inside the inner scope, we attempt to set the value of R's reference to X. I think this is the analysis that we did. Then the inner scope ends, and we attempt to print the value R. This code won't compile because the value R is referring to has gone out of scope before you try to use it. R is referring to, yeah, I think it's referring to X, which is out of scope after this line. Okay. The error message says that variable X does not live long enough. The reason that X will be out of scope in the inner scope ends in line 7, but R, yeah, oh, okay, that's our analysis as well. But R is still valid for the outer scope because its scope is larger. We say that it lives longer. Yeah. It's like R is global. Yeah. So even inside here, it still exists. Still in scope. Okay. So how does Rust determine that this code is invalid? It uses a borrow checker. Yeah. The fundamental concept in Rust. I think for those who will just glance through the Rust documentation without really following it in the right sequence, you'll miss out some important concepts. For me personally, I think it's quite difficult to just jump into certain topics here. And for me, I think I'm just testing out if we just go through the entire document line by line, then at the end of chapter 21, yeah, 21, it's quite exciting because we get to build a single-threaded web server. Oh, even multi-threaded server. Graceful shutdown and cleanup. Yeah, so these are exciting topics. I wish we could get there. Yeah. or we will aim for that. Okay, the borrow checker. The Rust compiler has a borrow checker that compares scopes to determine whether all borrows are valid. Yeah, yeah. Okay. Here we've annotated the lifetime of R with apostrophe A. No, single quote A. And the lifetime of X with B. Okay. As you can see, the inner block P is much smaller than outer A. Yes. Outer A lifetime block at compile time. Rust compares the size of two lifetimes and sees that R has a lifetime of A, but that it refers to memory with lifetime of B. The program is rejected because B is shorter than A. B is shorter than A. The subject of the reference doesn't live as long as the reference. The subject of the reference, which is X, doesn't live long as the reference. R is reference. Okay. Listing 10-18 fixes the code so it doesn't have a dangling reference. And it compiles without any errors. Okay, so how was it fixed? Yeah, of course, of course. X is here. Yeah. I mean, this is how we should code. They are in the same scope. Here, X has a lifetime B. Yeah, X has a lifetime B, which in this case is larger than A. This is A. This means R can reference X. Because Rust knows that the reference in R will always be valid while X is valid. Note that you know where the lifetimes of references are and how Rust analyzes lifetimes to ensure references will always be valid. Let's explore generic lifetimes of parameters and return values in the context of functions. Okay, generic lifetime in functions. We'll write a function that returns the longer of two string slices. This function will take two string slices and return a single string slice. After we've implemented the longest function, the code in listing 10-19 should print the longest string is ABCD. Okay, let's see. String 1, okay, ABCD is here. String 2, this is the str way of creating strings. And then let result longest. Longest is here. This is the main function. String 1 as str, string 2 result. The longest string is result. Okay. Note that we want the function to take string slices, which are references, rather than strings, because we don't want the longest function to take ownership of its parameter. We don't want the longest function to take ownership. Then it should be ampersand. Ampersand is here. Okay. Discussion. Okay. If we try to implement the longest function as shown in 10-20, it won't compile. Okay, so this one will not compile. Before we jump here, let's test ourselves. Let's do some analysis. Why it won't compile? Okay, string 1 as str. String 1 as str. Okay, this one is already suspicious. String 2, okay. str x y str. If x len greater than y len, okay, it's wrong. I don't know as well. What is wrong with this? String 1, string 2. Result. Okay, so we are borrowing. Okay, so because of as str, ABCD will look like this also. Okay. But does it mean that string 1 is already out of scope? No. We are referencing as str. For now, I'm clueless. There must be a trick somewhere here. An implementation of the longest function that returns the longer of two string slices but does not yet compile. Instead, we get the following error that talks about lifetimes. Okay, what does it say? Expected named lifetime parameter. Okay, so x and y could be x and y. Scope of x and y is here. Okay. This function's return type contains a borrowed value. Yeah, because of the ampersand, it's borrowed. But the signature does what? Does not say whether it is borrowed from x or y. What signature? What signature? Huh? Oh, you mean here? This one should have ampersand. Oh, okay. Let's try this out. That's what I initially thought. Let's see. Let's prove the theory that if you put ampersand here, actually borrowing. Might be wrong. Okay, so let's copy this. Here. Comment this out. Oops. Longest. So we need the function longest. So this one already complains. But the signature does not say whether it is borrowed from x or y. X. What I wanted to do is if we put ampersand here. We can remove that. Oh, it's even worse. Oh, something is here. It automatically suggests. Static str with a single quote. You only get to see that in Visual Studio Code. Okay, so let's go through. It says here, consider introducing a named lifetime parameter like this, longest. Oh, but why would I want a and not y? The help text reveals that return type needs a generic lifetime parameter on it because Rust can't. Okay. It's a lifetime A. Actually, we don't know either because if block in the body of this function returns a reference to x, and the else block returns a reference to y. Okay. Rust can tell whether the reference being returned refers to x or y. Actually, we don't know either. Okay. If the if block in the body in this function returns a reference to x, and the else block returns a reference to y. When we're defining this function, we don't know the concrete values that will be passed on to this function, so we don't know whether if case or the else case will execute. We also don't know the concrete lifetimes of the references that will be passed in. So we can't look into the scopes as we did in listing 10-17 or 10-18. To determine whether the reference we return will always be valid, the borrow checker can't determine whether the reference we return will always be valid. Because it doesn't know how the lifetimes of x and y relate to the lifetime of the return value. To fix this error, we'll add generic lifetime parameters that define relationship between the references so the borrow checker can perform its analysis. So this is where we fix that issue by using lifetime annotation syntax. So we cannot fix it at this point. Let's see. Lifetime annotations don't change how long any of the references live. Rather, they describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. Just as functions can accept any type when the signature specifies a generic type parameter. Functions can accept references with any lifetime by specifying a generic lifetime parameter. Generic lifetime parameter. Okay. Lifetime annotations have a slightly unusual syntax. The names of lifetime parameters must start with an apostrophe, and are usually all lowercase and very short, like generic types. Most people use the name A for the first lifetime annotation. Replace lifetime parameter annotations after the ampersand or a reference using a space to separate the annotation from reference types. Okay, here's some example. A reference to I32 without a lifetime parameter. A reference to I32 that has a lifetime parameter apostrophe A, and a mutable reference to I32 that also has a lifetime apostrophe A. Okay, so this is a reference. A reference with an explicit lifetime with the data type I32. Okay, a mutable, okay, that's a mute reference with an explicit write time. Okay, Let's make a guess. So now we know there's apostrophe A. Not fix this yet. What you can do, just comment it out first. And comment this out, but uncomment this out. And can I do something like A? That is wrong. Okay, so can we name it also like ah, this is not it. Cannot do it that way either. Okay, maybe let's just continue. Lifetime annotations in function signatures. To use lifetime annotations in function signatures, we need to declare generic lifetime parameters inside the angled brackets between the function name and the parameter list, just as we did with generic type parameters. We want the signature to express the following constraint. The returned reference will be valid as long as both the parameters are valid. This is the relationship between the lifetimes of the parameter and the return value. We'll name the lifetime apostrophe A and then add it to the reference as shown in 10-21. Apostrophe A, apostrophe A, apostrophe A, apostrophe A. Let that fix everything. Let's find out. So we'll have just like the traits. And here, apostrophe A. Is it correct? Here, where was it? Apostrophe A, apostrophe A. Percent apostrophe A. Yeah. So on percent apostrophe A. Let's do it here. STR. Oh, okay. You can still do it here. Apostrophe A. Apostrophe A. Apostrophe A. Okay. What is this one? Now there's no compilation error. Okay. Okay, let's read the explanation. This code should compile and produce the result we want when we use it in the main function in this thing 10-19. The function signature now tells us that for some lifetime a, the function takes two parameters, both of which are string slices that live at least as long as the lifetime a. The function signature also tells us that the string slice returned from the function will live as long as lifetime a. In practice, it means that the lifetime of a reference returned by the longest function is the same as the smaller of the lifetimes of the values referred to by function arguments. These relationships are what we want Ross to use when analyzing this code. Remember, when we specify the lifetime parameters in this function signature, we're not changing the lifetimes of any values passed in or returned. Rather, we're specifying that the borrow checker should reject any values that don't adhere to these constraints. Note that the longest function doesn't need to know exactly how long x and y will live, only that some scope can be substituted for a that will satisfy the signature. When annotating lifetimes in functions, the annotations go in the function signature, not in the function body. Okay, function signature, not in the function body. Okay, signature, okay, here, not in the body. So we don't have x apostrophe a here. Okay. The lifetime annotations become part of the contract of the function, much like the types types in the signature. Having function signature contains the lifetime contract means the analysis the Rust compiler does can be simpler. Okay, having function signatures contain the lifetime contract means the analysis the Rust compiler does can be simpler. If there's a problem with the way a function is annotated or the way it is called, the compiler errors can point to the part of the code and the constraints more precisely. If instead the Rust compiler made more inferences about what we intend the relationship the lifetimes to be, the compiler might only be able to point to a use of our code many steps away from the cause of the problem. When we pass concrete references to longest string to longest, the concrete lifetime that is substituted for apostrophe a is part of the scope x that overlaps with the scope of y. In other words, the generic lifetime a will get concrete lifetime that is equal to the smaller of the lifetimes x and y. Because we've annotated the returned reference with the same lifetime parameter apostrophe a, the returned reference will be also valid for the length of the smaller of the lifetimes of x and y. Let's look at how the lifetime annotation restrict the longest function by passing in references that have different concrete lifetimes. Listing 10-22 is a straightforward example. Okay, main string 1, okay, string 1, oh, now it's enclosed in this one. Longest string is long, string is long. Long string is long. So it considered string 1 as str. Okay. String 2 here as str. In this example, string 1 is valid until the end of the outer scope. So we can still use string 1 here. String 2 is valid until the end of the inner scope. Okay, end of the inner scope. Run this code and you see the borrow checker approves. It will compile and print the longest string is long, string is long. Okay. Yeah, we believe you. Okay. Next, let's try an example that shows that the lifetime of the reference result must be smaller lifetime of the two program arguments. We'll move the declaration of the result variable outside the inner scope, but leave the assignment to the value to the result variable inside the scope with string 2. Then we'll move the print line and use result outside in. Okay, that's quite long. So let's just try and see what's in here in the code. Okay, so result was defined here without any anything binded to it. So it doesn't have value. String 2 is this one, string 1 is this one, longest string. Okay, so this is supposed to return an ampersand str, but result is here. Attempting to use result after string 2 has gone out of scope. Why? I thought result is like a global because it's inside the main, and this one is a smaller scope. When we try to compile this code, we get this error. Okay, string 2 does not leave enough. Okay, understand. Binding string 2 declare here. Bar value does not leave long enough. String 2 drop here was still borrowed. Borrow later used here. Okay, the error shows that for result to be valid for the print line statement, string 2 would need to be valid until the end of the outer scope. Yeah, okay, because string 2 does not live long enough. Rust knows this because we annotated the lifetimes of the function parameter and returned values using the same lifetime %a. Okay. Okay. Here, the return. So the result, including the result will have that lifetime. But actually, result is somewhere here. As humans, we can look in the code that string 1 is longer than string 2, therefore result will contain reference to string 1. Because string 1 has not gone off scope yet, a reference to string 1 will still be valid for print line statement. However, the compiler can see that reference is valid in this case because we told Rust that the lifetime of reference returned by the longest function is the same as the smaller of the lifetimes of the reference passed in. Therefore, borrow checker disallows the code in listing 10-23 as possibly having an invalid reference. Try designing more experiments that vary the values and lifetimes of the references passed into the longest function, and how the returned reference is used. Make hypotheses about whether or not your experiments will pass a bar checker before compile, then check to see if you're right. Let's try this one. Result is outside. Okay. Long string is long. Long string is long. Here string 2 is now string 2. So string 2 we put inside. Put it here. Then you put let result. And here let's scope. Okay, we don't need this. Then result is just like this. This was there. String 2 xyz, string 2, string 1, long string is long, result. Okay, now it looks similar. We want to experiment. Result. Let's string 2 result. Says here it will have an error. String 1, okay, string 1, then string 2. Okay. String 2. So now we'll complain. Borrowed value does not leave long enough. Okay. First string 2 is here. Can we do something like, okay, so from here, we put, what can we do from here? I think we cannot change. Why? Can we experiment with this? I think it's providing a suggestion like this here. Double click to insert. Then and still get that error. Str. Generally it was like this. String to static str. Let's do this one. But we still have this error. This method is redundant. Okay. I think originally it was like this. Yeah. If we remove str, now this one complains. Because it's string with a capital S. Okay. S. So we take it as okay. Because string 2 is actually already this one. I think our knowledge of what is this? Lifetimes. Still quite limited for now. Maybe let's move on and see. Thinking in terms of lifetimes. The way in which you need to specify lifetime parameters depends on what your function is doing. Okay, so lifetime is usually in the function. If we change the implementation of the longest function to always return the first parameter rather than the longest string slice. Oh, there's no apostrophe A here. Okay, because we have apostrophe A here. But not for the parameter y, because the lifetime of y does not have any relationship with the lifetime of x, or the return value. Return value. When returning a reference from a function, the lifetime parameter for the return type needs to match the lifetime parameter of one of the parameters. when returning, okay, here, oh, this one is different now. X and Y doesn't have the apostrophe A. So this one will have an issue also. The reference return does not refer to one of the parameters. Yeah, because it is totally new. It must refer to a value created within this function. However, this would be a dangling reference because the value will go out of scope at the end of the function. Consider this attempted implementation. Okay. Yeah. The end of the function, the result will be dangling. The problem is that result. Okay, that's the understanding. Ultimately, lifetime syntax is about connecting the lifetimes of various parameters and return values. Once they are connected, Rust has enough information to allow memory save operations. These allow operations that will create dangling pointers, otherwise violate memory safety. Lifetime annotations in struct definitions. Okay, so this is struct. It's still quite long. Generic types, parameters, straight mounts, and lifetimes. I think for now, let's end here and continue on the following day. It has been a long day for now. And I think we still need to go through lifetimes once again. For me, it's not that clear. So I will just go back and really understand what lifetimes is. Before we move on to other topics, I think tests should be fairly easy, I would say. What do we have here? How to write tests. Okay, you have this, you have this, and assert. And then chapter 12 have something interesting, accepting command line. Oh, chapter 12, it shows that we are really doing something useful. I mean, it's already a full-fledged command line program, I would say. Okay, so looking forward to that. But for now, let's stop here and call it a day. All right. So thank you so much. Hope to see you in the next session. Bye for now.